Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Al-Mazamani. My metric number EAE190027. So I will present for the introduction. The electrodiagram or ECG is one of the common biological signal used in the detection of cardiac problems. The detection of QRS complex is one of the most significant aspects of ECG signal. QRS detection, particularly identification of R wave in heart signal, is easier than detection of other component of ECG signal. So for this project, my team, we are using MATLAB software to detect the R peak of electrodiagram or ECG. Okay, I think that's all for the introduction. So I will pass to my friend. Thank you.
Okay, next I'm going to explain about the methodology of this project, which is for the software use. We are using the MATLAB software to detect the RP of electrocardiogram ECG. And for the block diagram, as you can see, for the first step, we need to put the input and then removing low frequency component using the FFT. And next is windowing filter and thresholding and adjusting filter before we get the final output of the products. As you can see below is all the graph of the step we get. And then this is the final output of algorithm can be displayed as shown in figure below. For the calculation of heartbeat, we use this heartbeat in beats over second can be calculated by the formula of rate is equal to 60 times sampling rate over RR interval.
For the simulation in the MATLAB, we're gonna use two sample in here. So the sample will through the filter in here by removing a low frequency component using an FFT, and after that windowing filter and thresholding and adjust filter, and we get the output we get. So we're gonna run the MATLAB in here. So we get the average heart rate for the first sample, and this second sample average heart rate. So this is a result for two sample in here. We get this a process for the sample 1, and this a result for the RP ideal RP in here, and this for the result for sample 2. So then we're gonna discuss about the process. So the process, the RP using the filter for sample 1 in the sample first, we use a 44604 data of heartbeat was used with the 1000 sample rate. At the first graph, original ECG your input showed not an ideal ECG and stable. Change to frequency domain using FFT, and after that new output graph produced in the sample 2 in here, and then they remove. And then dia gonna remove the low frequency component by using a thresholding method. For the first filter is average filter, and then we're gonna detect the R peak in here for max signal, and then repeat back for the next filter and detect back for the next max signal in here. And finally we detected the peak or max signal at graph, and we're gonna use the inverse FFT, and then how we get sample 1 in here. So if we zoom it, after we zoom the sample 1, we get this graph with we get the ideal RP in here with this 4 ideal RP. So the sample 1 we get a 47 RP, and the heart rate is 54.87 BPM. So next for the sample 2, also the same process but different result in here. Yeah, after that we go comparing the result of the sample 1 and sample 2. We can see that number of sample 1 is higher than sample 2, and also the weight number of peak also 47 over the 21. However, average heart rate is sample 2 is higher than sample 1. So the conclusion is we get the effective and for stage methodology has been developed for automated detection of RP in ECG signal. So that's all from us. Thank you for watching.